I made myself sick.
Okay, I want to talk about 3 homework items that were the most that caused the most trouble. Numbers 1, number 7, and number 9. Mm-hmm. Oh, this is the wrong one. Oh my goodness. Here we go. Okay, so if you need to find h prime of 2, I can't make this any bigger, so I'll just kind of rewrite it over here. But this is basically saying that h of x is equal to f of g of x. And it's talking about finding the rate of change of h. So when you see this right here, what do we practice saying that is? Rate of change of h with respect to x. Okay? It's not h prime. H prime doesn't tell us anything. So we practice, it's the rate of change of h with respect to x. Okay? And what did we say? So we've got this composition function. And to find the rate of change of h with respect to x, we first would find the rate of change of f with respect to g as it is, right? And then?
Rate of change of g.
Good, right. Okay. So here it's saying g of 2 is -5. They said the rate of change of g at 2 is 1. What else do you need to calculate the rate of change of h at 2? Okay? First you're going to need what? You're going to need g of 2. Is that given? Oh, that was given. Okay, so it's given that that's -5. So what else do we need? The rate of change of f at -5. Okay, because we need the rate of change of f with respect to g. So at 2, at x equals 2, g is -5. So then we need the rate of change of f when x is -5. So that would be this one here. Questions on number 1? Did you catch it? Does it make sense? Anybody have a question? Okay, number 7. Okay, so this goes back to what exactly does this notation mean? So when you see that notation, what you have to see is that is it's sine of x all to the -3rd power. So that notation right there, you need to be very confident with what that notation is telling you. It's saying take the sine first, and then after you get the output of sine, then take that to the -3rd power. Okay, so what would this be? Cosine 5, cosine 5th of x would be? Cosine x all to the 5th. Okay, as opposed to this, cosine of x to the 5th. What's that mean? And then you'll take the cosine. So what happens first here? What happens first? X to the 5th, and then we take x to the 5th and we take the input that into cosine. This one, what happens first? Cosine and then to the 5th. So when you see this notation, Don't write this. This notation means we're going to do the cosine first and then raise the result to the 5th power. So that might have been half the battle here. But from there, so then what do we have? What's the structure? I'm going to ask this question a million times in the next week. What's the overall structure? Because that's going to govern what rule you initially apply. So what's the overall structure?
Subtraction of function.
Oh, right. Okay. So the overall structure is difference of functions or sum. So how do we do that?
Take them separately.
We're going to do each. So we like this rule, right? Because the difference of functions, the rate of change is just the difference of the rates of change, right? So now we get to this first one. What's the overall structure of sine x raised to the negative 3?
X to the negative 3.
Power rule, right? Power rule. So our exterior function is to the negative 3. So we're going to do the power rule, which is negative 3 to the negative 4. Now the question is, what goes in here? X, sine x, or cosine x? You leave it as it is. Interior function as it is. Remember, if it's p of q of x, the first thing we do is the rate of change of p with respect to q. Rate of change of p with respect to q. So we're doing the rate of change, the p is the negative 3 function, with respect to that interior function as it is. Then times the rate of change of, in this case, q would be sine of x, which the rate of change would be cosine x. Similarly, rate of change of something to the 5th is that something to the 4th times 5, and then now times the rate of change of the interior.
Negative sine x, which basically makes it an addition.
Right, you could make that those two together make plus. That's right. Questions on this one? What's that?
I said it makes a lot more sense knowing that.
Yeah, it's just going to take some practice. Knowing that what?
No, just knowing that the sine to the negative 3
Yep.
x is including all of that.
Yep, you got to know that off the top of the bat. Other questions? Okay, last one, number 9. Of course. All right. So what's happening here? We've got cosine. The function is cosine 7th sine 8x. So what we have here is it's a chain rule within the chain rule within the chain rule, like it's layered down. Okay, so the first thing is overall structure. Power rule to the what? So we could rewrite this as the original function as cosine of sine of 8 of x. And that thing, all to the 7th. So we're going to find the rate of change of that. The first thing we're going to do is 7 to the 6th. What will go in here?
Cosine of sine of 8x.
Right, it's just going to be this thing as it is. Okay, then times the rate of change of the interior, the rate of change of the inside. Okay, what's the overall structure of that?
Negative sine of sine.
No, that's the rate of change. What's the overall structure?
Cosine.
Cosine, right? So what's the rate of change of cosine? Negative sine. So everything below this is going to be the rate of change of this. Okay? Which is outer function's cosine, so the rate of change is negative sine. But then times The sine of 8x? No, the rate of change of that. Then, again, we have another. So, looking at just the rate of change of sine of 8x, it's going to be the cosine of the interior times 8. So, everything below here is the rate of change of this interior function right there. Everything below here is what? The rate of change of that. And then the 8 is the rate of change of the interior of the last one. So it's like 3 deep of chain rule.
And then, I mean, the answers that they gave, did they take 8 and multiply it by 7 at the beginning?
Maybe.
Yeah.
But you should be able to put in, like this. It should still count it right.
Yeah.
If you just put it in like this. Okay. Anybody have a question? Last chance. Any questions?
It was something raised to like the third power. I forgot how it was.
We can do. I was asking about that run. If you want to do more questions after class, if you want to stop after class, we'll look at some more for sure. I'll just leave this window open. Okay, we got more rules. Okay, what we haven't dealt yet with is products or quotients of functions. So here's an example of, we've got two original functions f and g. We could make a new function h, which is the quotient of f and g. And we could make a new function k that's the product of f and g. So the immediate question that arises is the rate of change of h the quotient of the rate of changes, and is the rate of change of k the product of the original rates of change? So what rule did we have before that was like this? Where it was kind of exactly what we wanted, right? Exactly what we wanted. What rule was like that? The sum rule, right? So if we had, say we made a function p was f of x plus g of x, or minus g of x. What was the rate of change of p?
Rate of change of x.
Yeah, this is like falling out of bed, right? And you've gotten some practice doing these. So, wouldn't it be nice if the quotient of functions, the rate of change was just the rate of change of its quotients and products as well? Yeah, exactly. Wouldn't it be nice? It's not true. Okay, oops. Back too far. Okay? But calculus students throughout the ages have tried thousands of times to make this be the rate of change of the quotient and this be the rate of change of the product. So, fair warning, don't do that. So what happens is you're in a greater context, like an application problem, and you have a short, along the way, there comes a derivative that you need, a rate of change function that you need, and because you're in this larger context, and it's maybe it's not such a complicated function, you just forget and you do that. And that's very common, so just be careful. Whenever you have a function that's a quotient, or whenever you have a function that's a product, you need to apply the rule that we're going to derive today. You can't do this. You can't do this. Okay, so product. So if we want to find the rate of change of the product, how could we start? Done it a dozen or more times. How would we have to start to kind of try to come up with a rule for the rate of change of the product? See if you can write it down. How would you start? many people think they know? Please, more than one. 3, 4, 5, 6. How would we get started if we wanted to actually create the rule for the rate of change of any function? How about any function? Call it q of x. No, any function. I want to start. What's that? So, Stanley.
Start with f of x plus h minus f of x.
That's not what this function is, right? You got the right idea, but we're working on this function, right? Oh, so wait, so say it again, what you're going to say?
So f of x plus h minus f of x.
So that's the rate of change of f. That's not this. We need to start with the rate of change of f times g. So see if you can do it.
So to do the same thing.
Stanley.
So I'm not seeing it right away.
Okay. Yeah, Connor.
Did you do something like that? You said f of x plus h times g of x plus h minus.
Okay, yeah, eventually, but it's this function right here. Yeah, that's right. That is right. But we don't want to skip the step. Okay, so Judith.
So is it f times g of x plus h minus f times g of x over h?
Got to learn this. This is our rate of change function, right? Is this approximate or exact?
Approximate, you have to have the limit.
Yep, if we're going to do exact, we'd have to have the limit. Okay, but it's essentially equal when h is very small. There's essentially equal, right, when h is very small. Okay, so that's all we know how to do. If we want the rate of change of f times g, that's all we know how to do to start. Okay, and so that what I wrote then is the same as this, and this is what Connor was saying. Okay, this is what Connor was saying. So the f times g of x plus h, well, that's this right here. And f times g of x, that's just f of x times g of x, all over h. So from here, we need to string along inequalities. Remember, a equals b equals c equals d equals e, all the way to some kind of rule that we'll have that will give us the rate of change without the h's, right? Without the h's. Okay, so there's a trick that you wouldn't know unless someone showed you, okay? Or you could spend, a year trying to do things until you figured it out. But so we'll just show you the trick. The trick is to subtract f of x times g of x plus h, but then to add f of x times g of x plus h. Why can we do that?
Then you can factor the whole.
No, why can we do that?
Oh, because you're basically subtracting and adding the same amount.
Yeah, because it's 0, right? So all I did was I just put 0 in there. So it's still equal to the one before, right? Is it okay? So why do we do that? Why do we do that? Because it works. Connor, you were going to say.
Oh, because can't you factor it into its multiples? Or
Okay, so the reason we do it is
factor out?
I'm going to group together the first two. I'm going to group together the last two. Okay? So I inserted 0 in there in the form of a minus and plus of the same thing. Then I'm going to take the minus, and I'm going to group it with the first term over there. And then I'm going to take the plus and group it with this one here. And then in this next step, what do you notice? There's a g of x plus h, and factor it out. So there it is factored out. And then what can we factor out of this?
F of x.
F of x, okay? It's just algebra. Okay, then, so if h is kind of like a common denominator, we can split it up into two fractions, where h is our common denominator in both cases. So I'm grouping together. Ah, jeez. So what did I do? I grouped this right here like this, and I grouped this right here like this.
And those are the rate of change functions.
So, do you recognize that right there and that right there? Somebody in the back. What is this right here? Who's? Yeah, Daniel. Which rate of change? Which one? Okay. But rate of change of what function? Yeah. So it's the rate of change of f. This is the rate of change of f with respect to x, right? We recognize that. What about this one? Rate of change of g with respect to x. So what happens as h gets very, very small? What about g of x plus h? This is g of x, right? And we know what happens when h gets small. We get the rate of change of f here. And when h gets very, very small here, we get the rate of change of g. And so we end up with this rule right here. So this is the second function. So I just rearrange things. Or the first function times the rate of change of the second plus the second function times the rate of change of the first. Okay, notice that that's not equal to what? What is that not equal to? The rate of change of g times rate of change of f.
So what you just said.
Don't do that.
You said so you take f of x.
The first function.
So the first function times it by the rate of change.
Times the rate of change of the second.
Function, and then add the
Plus
second function.
Swap it.
Times the rate of change.
Yep. Yep. So this one's easy to remember. There's a nice symmetry to it. Does it matter which one of these come first in the plus?
No.
No. And then does it matter when you multiply which one comes first? So any way you want to remember this, you just, if there's a perfect symmetry to it. You take one of the functions times the rate of change of the other, then you add the reverse, the switch of it, right? And take the other function times the rate of change of the first. But watch out for this. So, like I said, in a context of a word problem or you're doing lots of other things, that's where this will sneak up on you, and you'll find yourself doing rate of change of the first times the rate of change of the second. Anytime you have a product and you want the rate of change, you have to use that one there in blue. Okay? Two different ways to write it. So here's in the prime form. It's the prime form. This is in the R function form. But they're both exactly the same. So let's practice. So we'll call the first one G, say, and the second one H, because they're calling the function f. We don't use f be one of our two. So we'll call one of them G and one of them H. All right? So let's start by doing what's the rate of change of G with respect to x? Adelaide, what's the rate of change of G with respect to x be? What's that? Stop. That's it. Yeah. Yeah. 8x to the third, right? And Stephanie, what's the rate of change of h with respect to x? Yes. The rate of change of h with respect to x. 6x? That's right. So there's our rate of change of g, 8x cubed, rate of change of h, 6x. So now the plan is, what do we have? We have a product, so we're going to use the product rule, which says take the first times the rate of change of the second. So here's the first, g, times the rate of change of the second plus the second times the rate of change of the first. Anybody have a question? Do you see how? Yeah, Judith.
If we happen to write it like in a different order on the on our answer,
Okay.
are you gonna mark us down? Because I've learned this before, and I kind of have like an order that I still do.
Okay. So if you change the order, is it a different function?
No, but I didn't know if you were gonna be super picky.
We just need to get the right function.
Okay.
Yeah, we just need to get the right function. What's that? So yeah, so you can switch these, and you can switch them, and it's still the same function. It's still the same function. Any other questions on this? Okay, so what we can do is to find the quote. So that's an example of the product rule. To find what we call the quotient rule, we can now use the product rule because we can write a quotient as a product. How can we write this quotient f over g as a product? Talia, how could we write that quotient f over g as a product? Okay, and so now if we want the 1 over g of x not be a quotient, yeah, so we can write f over g as f times g to the negative 1 power. And we have the same function, and now we can apply the product rule, and then that can derive for us a quotient rule. Okay? So what will the product rule be? So I want you to just, with the person next to you, explain this right here. Explain what's going on here, and why is this the next step, and what does this mean? Okay, go. Explain to the person next to you. What does this mean? Why is it the next step?
So that's just the rate of change. So that's that bottom line. That's what that's times the rate of change in G. Plus the rate of change. First. Times we're heading towards the one.
Okay, Marcus, go. That was good. Marcus.
The first one
First one
times the rate of the change of the second
times the rate of change of the second plus
the second
second
times
the rate of change of the first, right? So that's just applying. What is that applying right there? Product rule. That's what we just derived. Okay, it's applying the product rule. Okay. So when we get to the rate of change of the first function here, or second, sorry, rate of change of the second function, what's that going to entail? What do we got? We're doing the rate of change of this right here. So we ask ourselves, what is the structure of that? Yeah, Dave? He wants the chain rule with the outer function being to the negative first. What it is, right? So we're going to use the power rule first with the negative 1 power, and then we'll have to chain on the rate of change of the inside function. So there it is. So what is the power rule for that? The power rule would be negative 1 to the negative 2 with respect to g, then times the rate of change of g. Did you see what happened? Does it make sense? Okay, so then we don't have to go. This is just algebra to rearrange it. So we're not going to take the time. This is just all this is just algebra. It's just rearranging things until we get it to look like this. Okay, so here's what we end up with then. The rate of change of the quotient f over g is what? The denominator times the rate of change of the numerator minus the numerator times rate of change of the denominator over the denominator squared. Okay? And that's the result of, so you should understand this product rule, and then you're not going to take the time, but that's just algebra to change it around. We get this. Okay? So this is using the R function form. This is using the prime form. They're exactly the same. Just two different ways of expressing the rates of change. Anybody have a question? Yeah?
In this one, would it matter on the numerator?
Because?
Because that's gonna be a negative denominator.
Yeah. So she's pointing out, this is good, she's pointing out that because it's subtraction, you can't switch a subtraction and get the same thing, right? So the order is important. So this one is takes a little more effort to memorize than the product rule, but here's...
Not only is the order important, but knowing which one's the quotient and which one the denominator and numerator is as well.
What's that?
Well, I was just saying it's important to know the denominator and then
That's right.
use that one as the non-derivative.
Right.
Yeah.
Okay, so here's a little... okay, so here's a little... so here's this is a little trick. So if you call the g function low, because it's the denominator, right? And the f function high, because it's in the numerator. Then you get this little chant. Low d high minus high d low over low squared. Okay? So you don't have to use that, but this is just a little song you can sing to help you remember this, because it takes a little effort to remember. So low d high minus high d low over low squared, and it's off to work we go, right? This way too, you guys don't get that. All right, so
Get it?
some of you, so hi, right? All right. Product rule, there's perfect symmetry to it, pretty easy to remember. This takes a little more effort, so here's something that might help. Okay. So really then, all you have to remember is the first part. So this is the only part you need to remember, because the rest will fall into place after that, because if it's low d high, it's going to be minus what? High d low. So if you just can remember that first little part, and remember that it's over low squared, you got it. Okay? All right, so try it. Try to find the rate of change of h for this one. Find the rate of change of h for this function, should be sine over e to the x. Okay, Jacob, do you have some success with this?
I've got e to the power of x minus cosine of x.
So e to the power of x,
Cosine of x
okay?
minus sine of x. I don't know how to use it.
So what's the rate of change of e to the x? E to the x, remember? Yeah, so it's going to be low d high minus high d low over low squared. Any questions on that one? Okay, quick, do the product rule on the same one. Piece of cake, product rule. So what's, if k is the product of those two, what's the rate of change of k? David, you get it?
So the rate of change.
Yep,
Sure. Oh, okay.
tell me.
It would be, I don't know which words to put in, but cosine of x times e to the x plus e to the x times sine of x.
Okay, so he did the rate of change of the first times the second plus the first times the rate of change of the second, that's fair.
I think you forgot the negative,
Don't be any negatives in this one. Because it's plus, and the rate of change of sine is cosine, not minus sine. Okay, so we need some harder examples. How are we so far? Good? Okay. All right, so the whole point of these is, can you use these rules in combination? So there's functions that will use 2, 3, 4 of the rules, all of them. But how do we start? So what's the key to getting started? What question do you ask? What's the big picture? What's the structure? What's the big picture or the structure of this? That will govern the big picture or the structure of how you approach the rate of change. David?
First, after I answer, could you read the e to the something?
Sure, e to the minus sine of 3x. So the denominator is e to the minus sine of 3x. Okay, so what is the overall structure or the big picture of it? Just forgot your name for a second. Andrew. The quotient, okay? So we're going to look at this in the quotient rule. So what is our f function? Sine of cosine of x. And our g, or our denominator, is this one I wrote up there in the corner. So we can start by finding, we know that as part of the quotient rule, we'll have to find the rate of change of each of these. Okay? So how do we find the rate of change of sine of cosine of x? DJ?
We find the rate of change of sine.
So as part of the, we know that the quotient rule is going to be our overall game plan. I think that's the next thing here. So yeah, so R of H is going to be the quotient rule. As part of the quotient rule, we're going to need the rate of change of F, and we're going to need the rate of change of G. So let's find those first. So what's the rate of change of F?
So it's going to be cosine of cosine of x.
Okay. Cosine of cosine of x. Is that it?
Yes. We have to find the cosine of x first. Like the.
No, that was a great start. Remember, but the chain rule, the whole point of the chain rule is that you then chain on
Okay.
So we take, so now the big picture of that for the rate of change is chain rule. So we want the cosine with respect to, the rate of change of sine with respect to cosine would be cosine of cosine of x, and then times the rate of change of the inside. What about the rate of change of g? Okay, the rate of change of g is, what's the overall structure of that? Not power rule. What's the overall structure of, don't look at this. Look at this. What's the overall structure of e to the minus sine 3x? E to the something. E to the x, or e to the something. So the rate of change will be e to the something, and then times?
Rate of change.
Times the rate of change of that interior function. Rate of change of minus sine 3x will be minus cosine 3x times 3.
So where did the negatives come from? We were. Oh.
So the way that this is kind of all changed, it's all switched around from how you might start writing it out. So what would you write first? You would write, this would be first. This is our rate of change of the outer function. Then times negative cosine x, 3x would be second. And then times 3 would be third. The rate of change of the interior function.
So the rate of negative sine is negative cosine.
Yep. Because it's negative 1 times sine, right? So that's our constant multiple rule.
And then
So this is first.
negative 1 times 3.
Then times the rate of change of the inside would be negative cosine 3x. Then times the rate of change of the inside of that, which is 3.
It was written out that way, I don't understand.
Okay, so now we're ready to, we've got everything we need to apply the rule. If we find the rate of change of this, it's quotient rule, we've got all the parts of the quotient rule now. So notice that within the quotient rule, we had chain rule. And this is very common. You have to use the rules in combination. Within the quotient rule is the chain rule. So if we could just write it all down. There it is. Low, d high, we found there, minus high, d low, over low squared. Yes, sir.
So for homework, would we just mention any method that, or should we try to find things to simplify?
So for the mastery test, this is it. You're done. I'll try to give you fair warning on certain MyMathLab problems if you're going to need to simplify or not.
Because there's times where I got it that like said your answer is right, but it's in the wrong form.
Does it give you credit for that?
No.
Oh, it doesn't give you credit? Okay. I'll try to give you warning.
I didn't simplify on any of them, and it gave me credit for all of them.
Did it worked?
Yeah, I got. Yeah, it'll go through. If you got all your parentheses, it'll go through.
Okay. I don't know what's happening with yours.
Lots of brackets.
I don't know. It was
You probably-
on one. I don't know. It said your answer is equivalent to the right answer, but it's in the
I've never heard that message before.
I think I got that before.
Okay. So, any questions on this example? Okay. So what's the game plan? Overall structure. Figure out the overall structure, and that's going to govern what the rule is. That's first. Second, get the pieces that you need. Then third, apply the rule of the overall structure of the problem. Okay, so this is just a list of what we've done so far, but I want you to try one more example in the last couple minutes. So this is what we're starting to work on now. We have all these rules now. We need to use them together. Yeah. Monday.
Yes.
Monday's the first attempt, and Friday you'll have like a I don't know what you call it, primer. Like Friday's recitation will be like a mini mastery to see if you're ready or not, and then you have the whole weekend to get ready. Okay, and that will count as a quiz. Yeah. Okay. So here's tangent. Let's skip that because it's too easy. Do just apply the quotient rule. Okay, and when you do all the math, you get secant squared. Okay, so new rule. The rate of change of tangent is secant squared, and the way you can find that, because tangent is sine over cosine, is use the quotient rule. Okay, go. See what you can do.
So the rate of change of tangent is secant squared.
Yep. Rate of change of tangent is secant squared. 2 minutes. See how much progress you can make. Find the rate of change of Q.
Wow, this is just a delightful problem.
So we don't have time to really get all the way through this. So rather than try to finish this, why don't you talk through the game plan with the person next to you? So what will the strategy look like from beginning to end? Okay? Talk through the strategy with the person next to you. Go.
And then at the bottom. It's gonna look something like and then D of 5, so you can product from here, or we find this whole thing. I would probably expand this. Make it one person. Have a little boil it to make it one. For multiplication purposes, and then D low. So all over it, E to the X.
Okay, so if you said the overall structure was quotient rule, you're correct. In the quotient rule, though, when we have the rate of change of the numerator, how are we going to get the rate of change in the numerator? You'll need the product rule just for that one part of the quotient rule where it's the rate of change of the numerator. So here's the product rule worked out, which is this is the rate of change of, or D high, this is D high, and this is D low, right? So now we're ready to set it up. What is it? Low, D high, product rule, minus high, D low, and low squared. Okay, there'll be another My Math Lab for Friday.
Is he gonna have
You're actually going to grade it in class.
Oh,
Yeah, you'll spend a half of class doing it and then have to grade.
making sense at all?
If the bottom had been like 4e to the 4x, would the rate of change be 4e to the 4x still?
You need to use chain rule for your D-low.
So it'd be
What's it called again?
4e to the 4x, so you're
So that makes it
4e to the 4x
times 4 e to the 4x times 4. 16, yep. Yeah, hold on, let me turn the video off.
I've actually probably